We know that models are important in math. We've learned that math models need to accurately represent God's created world. Our essential question today is, why do some people's mathematical models contradict reality? We talked earlier about how some scientists say that the Earth is thousands of years old, while others say the Earth is billions of years old. Why is that? What do we base our models on? We'll answer that question at the end of this lesson. For your daily review, you'll be practicing place value. It's been a while since you've done that, so take full advantage of this great review. I told you last time that today we're going to be sending variables to their rooms. We're going to learn to isolate them. What math symbol can you write to make the number sentence true? An equal sign. Both expressions have a value of 12. An equation is kind of like a balanced scale or a teeter-totter. Any operation that is performed on one side of the equation must also be performed on the other side to keep those expressions equal or balanced. Let's use counters to model this equation. 7 counters plus 5 counters equals 12 counters. The two sides are equal or balanced. If I remove 5 counters from the left side, are the expressions still equal? No, 5 counters were removed from only one side of the equation. 7 plus 5 minus 5 does not equal 12. We can see that with our counters. 7 does not equal 12. What do I have to do to balance the values on both sides of that equal sign? Well, since I remove 5 counters on the left side, I have to remove 5 counters from the right side to keep that equation balanced, to keep that teeter-totter from tipping over to one side. Whatever we do to one side of the equation, we have to do to the other side of the equation. So if I subtract 5 from both sides, the equation is still balanced or equal. 7 is equal to 7. So whatever we do to the left side of the equation, in order to maintain the balance, we have to do the same thing to the right side of the equation. If we don't do that, then we're no longer going to have balanced or equal equations. Let's use that same equation and remove counters, but we're going to keep that equation balanced. Last time we removed 5 counters, which was that second addend. This time, let's remove the other addend. We'll remove 7 counters from the left side. So what do we need to do to keep that equation balanced? Remove 7 counters from the right side of the equation. I'll write minus 7 in both equations to show that we removed 7 counters on both sides. The equation is still balanced, still equal, because 5 equals 5. When we subtract from both sides of the equation an amount that is equal to one of the addends, it cancels out the value of that addend on one side of the equation, making the value of that expression the other addend. Since we subtracted 7 from both sides, the value became 5, which was the value of the other addend. Can you keep the sides balanced and add counters to each side? You can, as long as you add the same number to both sides. We'll start with the same equation again. How about if I add 3 counters to the left side? What I do to the left side, I have to do to the right side, so I'm going to add 3 counters on the right also. To show that in the equation, we put plus 3 on both sides. Is the equation balanced? It is. 15 equals 15. So how do we use this process to find the value of a variable in an algebraic equation? We're going to isolate the variable or get it by itself. I'll model it first so you can see it. What algebraic equation can you write for this sentence? The sum of a number and 5 equals 8. The word equals tells us that an equation is needed, and the word sum tells us to add a number and 5. N plus 5 equals 8. Now to model this, I'm going to use a square for the variable and counters for the numbers. Remember, our goal is to isolate the variable. N plus 5 equals 8. How can we get n all by itself? We can subtract the 5 counters on the left side of the equation. Now, when we do that, what else do we need to do to keep that equation balanced? We need to subtract 5 counters from the right side. Now, I'm going to show that in the equation by subtracting 5 from each side of the equation. Subtracting 5 from the left side of the equation cancels out the second addend. Plus 5 minus 5 is 0. On the right side of the equation, we have 8 minus 5, which is 3. So what does n equal? It equals 3. Now, how could we check our answer to make sure that we're correct? We could substitute 3 in place of the n and see if the sides are balanced or equal. 3 plus 5 equals 8. That is correct. To isolate the variable in that addition equation, we used the inverse operation. We subtracted. Get that practice notebook ready. I'd like you to solve the next one with me. Write 4 plus x equals 15. What do we want to isolate? The variable. Now, to make this easier to solve, I'm going to apply the commutative property of addition, and I'm going to switch the order of those addends. Having the plus sign directly in front of the 4 just makes it easier to see that to isolate the variable, we need to do what? Subtract 4 from both sides of the equation. So we have 4 minus 4 plus x equals 15 minus 4. So what's the value of x? X equals 11. I'm going to do one more with you, and then I'd like you to solve one solo, so make sure you're paying attention. 7 equals 2 plus n. How do we isolate the n? Subtract 2 from both sides. 7 minus 2 equals 5. Since we're finding out the value of n, we want to write the n first. Say n equals 5. This one's for you. Find the value of n if 6 plus n equals 10. Are you subtracting 6 from both sides? That's what you needed to do. N is equal to 4. Now keep your brain engaged. This time we are going to isolate the variable in a subtraction equation. What's the inverse operation of subtraction? Addition. What operation is being performed in this equation? 4 is being subtracted from x. So what do we need to do to isolate that variable? We're going to use the inverse operation. We need to add 4 to each side of the equation. That's going to cancel out the 4's on the left side because minus 4 plus 4 is 0. And what will x be equal to? X is equal to 6. Is the solution correct? Yes, when we substitute 6 for x, we have 6 minus 4 equals 2, which is true. You want to try your hand at that? Let's do one together, and then I'm going to have you work independently. What do we do to isolate the variable? We need to add 5 to both sides. So what does c equal? C is equal to 19. All right, you're on your own. What's the value of j? You got it? Add 7 to both sides, and j equals 28. We've been just using whole numbers in our equations. But just so you're aware, algebraic equations might have decimals and fractions too. We're still going to solve them the same way. We're going to use the inverse operation to isolate the variable so that you can find the value. Let's simplify an equation with a decimal and one with a fraction. First, are there any like terms that we can combine? Yeah, we can go ahead and subtract 9 and 4/10 minus 2. Neither has a variable, so we can do that subtraction. Now we have 7 and 4/10 plus d equals 13. Isolate the variable. I'll subtract 7 and 4/10 from both sides of the equation to keep it balanced. What does d equal? 13 minus 7 and 4/10 is 5 and 6/10. Super fun, right? All right, now let's simplify one with a fraction. You can do this. What should we do first? Well, there are no like terms to combine, so we need to go ahead and isolate the variable. We'll add 3 and 3/4 to each side. What does m equal? 2 and 1/4 plus 3 and 3/4 equals 6. Now we could check this by plugging in 6 for m. 6 minus 3 and 3/4 does equal 2 and 1/4. You've learned that it is important that mathematical models match real life. What could happen if somebody failed to find out if his model matched reality? Well, the model wouldn't be true to the object or idea that it was representing. Here's an example. Ava learns that a baby grows 1/2 inch to 1 inch per month and gains 5 to 7 ounces per week from birth to 6 months of age. She makes a model to represent that growth and, based on the model, predicts that a child at age 11 will weigh at least 200 pounds and stand about 10 feet tall. Does that model match a child's actual growth? No. Are you 10 feet tall? What assumption did Ava make, or what wrong idea did she accept as true? That children grow at the same rate as an infant throughout childhood, but they don't. Infants grow at a quicker rate, but then the growth slows down a little after 6 months and again after 1 year. Otherwise, we'd end up with giant children who would probably try to take over the world. What went wrong with Ava's model? Well, it was based on a wrong idea or an assumption. Some people check to be sure that their model matches real life, what God reveals in nature. If a model is based on a wrong assumption, it's not a good model. The student who doesn't check that the model matches reality may believe the model and look to it as a source of truth. Why do some people's mathematical models contradict reality? People may use incorrect assumptions to determine what is true. Enjoy completing your assignment today. Send those variables to their rooms by using the inverse operation. We'll continue isolating variables next time as we solve multiplication equations. How do you think we're going to isolate a variable in a multiplication equation? Be ready to answer that next time.